Methods of removal of hardness from water. Methods of removal of hardness from water, or we can also say the process of softening of hard water. Softening of hard water. There are various methods. One of the methods is boiling. Boiling removes hardness only when the water is hard temporarily. Only temporary hardness is removed. By this process. Soluble bicarbonate convert into carbonate, carbonate being insoluble, whether it is the bicarbonate of calcium or the bicarbonate of magnesium, this is one of the methods. Simply the insoluble carbonates can be filtered. The second method is by addition of quicklime or even slake lime can be taken, but it must be taken in the calculated quantity. By addition of quicklime or slake lime in calculated amount. See what exactly is the process going on. Quicklime is calcium oxide, slake lime is calcium hydroxide. So whether you take quicklime or slake lime, it must be again in the calculated quantity, because the bicarbonate converts into carbonate on reaction with this compound. Once again the carbonate is precipitated out. You can observe here once again that the hardness due to bicarbonate can only be removed by this process, because the bicarbonates convert into carbonate, calcium carbonate. Due to this, the quicklime method or slake lime method, in calculated amount we are taking these substances, but method is again applicable for the removal of temporary hardness from water. Only for temporary hardness. Only for the temporary hardness. In fact, for the removal of temporary hardness. Only for the removal of temporary hardness. Now we have one more method by which hardness can be removed, because now the question is about permanent hardness. if the sample of water has permanent hardness, what will be the method to remove it? Here we have one more method, that is called as washing soda method. I hope you know what is washing soda. Washing soda is sodium carbonate. Hydrated sodium carbonate is called as washing soda. This is a water soluble compound, but when any of the calcium or magnesium compound in the form of chloride or sulfate, because we have 4 compounds here left which are permanent hardness causing agents. So I have selected calcium chloride. Due to the double displacement reaction, this calcium carbonate is precipitated. I take one more case. A similar thing will happen with magnesium chloride also, right? Here I have taken magnesium sulfate. A similar reaction will take place with calcium sulfate also, right? So in this case the product is once again magnesium carbonate. So washing soda method is used to remove permanent hardness from water. These are the methods which are commonly used not for the bulk level treatments. When large quantity of water is to be converted in the form of soft water, then we have some industrial processes. The industrial processes of softening of hard water includes number 1, ion exchange method. Ion exchange methods. Before going to the ion exchange method, in fact we have 2 different kind of methods in ion exchange process. Before coming to the details of such methods, let us talk about the principle behind ion exchange methods. Here we use ion exchanger chemical substances. Try to understand. I am using the word, there are certain chemical substances used as ion exchangers. They are packed in a column, and when hard water is allowed to pass through it, since the hard water contains calcium or magnesium salts, exactly a double displacement reaction starts taking place. When this double displacement reaction starts, the corresponding ion exchangers exchange their cationic or anionic part along with the ions present in the hard water. So by this exchange, the exchanger traps hardness causing ions and allows the non-hardness causing ions, or the ions which do not give hardness to water, to flow with the water. How does it happen? Let us take 2 different examples of ion exchange methods. Number 1 is permutate method. The permutate method involves ion exchanger substance called as zeolite. This zeolite is an inorganic compound. Zeolite is an inorganic compound. The formula for sodium zeolite, Na2 Al2 Si2 O8 dot XH2O. This is exactly sodium aluminosilicate. The compound sodium aluminosilicate is commonly called as zeolite. The commercial name for zeolite is permutate. So the chemical substance sodium aluminosilicate is actually called as sodium zeolite, or the commercial name for this compound is permutate. So we say that the method involves inorganic compound as ion exchanger, and the method is permutate method of softening of hard water. The process is very simple. This is an earthen substance, right? Zeolite is a type of sand, you can say. It is packed in a column. A column is packed with this solid substance. Zeolite is a solid, as I said, it is like a sand. So it is packed in a column, and from top of the column the hard water is added and rinsed through the column and collected at the bottom. When water passes through this column from top to bottom, during this flow the sodium zeolite, for convenience I am writing Na2Z rather than writing this entire formula. I have written Na2Z, so it represents sodium zeolite. It comes in contact with the hardness causing calcium or magnesium ions. The calcium or magnesium ions present in hard water, they start exchanging with the sodium ions present in permutate. Now the calcium zeolite is now left in the form of calcium zeolite. Previously, before passing water through it, it was in the form of sodium zeolite. But when hard water is passed through it, the calcium ions have exchanged the sodium ions. Remember, it is not a displacement, because displacement process has a principle of redox reactions, redox changes. When the displacement of one atom by the other atom is possible on the basis of their reactivity. But here the process is double displacement, not displacement. I repeat, displacement means a redox change, but double displacement means the exchange of ions only. So double displacement is usually favored with a precipitation. Since this is an insoluble substance, the zeolite is having sodium ions soluble in water, but calcium ions, they remain insoluble with the zeolite. So they are trapped with the zeolite and exchanged with the sodium ions. Sodium ions are exchanged by the calcium ions. So now the sample of water will be having sodium ions. Let us assume that the hardness causing agent was calcium chloride. Let us assume the hardness causing agent was calcium chloride. What will happen? Sodium zeolite in the permutate, in that ion exchanger column, calcium chloride in the hard water, exchange process has gone. After this process, calcium zeolite, now that column is packed with calcium zeolite and sodium chloride has gone with water. Please remember, this sample of water is a salty water. It contains sodium chloride. If it was calcium chloride, then the water contains sodium chloride. If the hardness causing agent was calcium sulfate, the sample of water will have sodium sulfate. If the sample of water was having magnesium chloride, the soft water will have sodium chloride. If again it was magnesium sulfate in the hard water, here we got sodium sulfate. So after softening, the water has salt, either NaCl or Na2SO4, sodium chloride or sodium sulfate. So that sample of water is a salty water, but remember it is not hard, because the hardness causing agents are only the 6 compounds. No any 7th compound is there which will create hardness to water. So that way, this is one of the ion exchange methods. Now in another ion exchange method, we use the organic substances in the form of ion exchanger. Organic ion exchange method. This method involves ion exchanger substance in the form of resins. For softening of hard water, different types of resins are used. Resins are the natural polymers classified into 2 categories. One of the type is acidic resin, another is basic resin. The acidic resin provides H plus ion, and the basic resin provides OH negative ion. Look at the matter in detail. First I write the resin part and then we shall continue with the softening process. See, the method now is a little bit different in the arrangement, in the setup. In permutate method, we have single column packed with this sand, that is zeolite, and hard water was allowed to pass through the top of the column and collected at the bottom of the column. Now in this method we have 2 different compartments. One by one the hard water will be allowed to pass through both the compartments. In first compartment, acidic resin will be packed, and in the second compartment basic resin will be packed. When water will pass through these compartments in one by one steps, then in the very first step the acidic resin is considered to be cation exchanger. It is considered to be cation exchanger, since it will exchange the cationic part of hardness causing agent. I have mentioned it because I had shown 1 H plus with resin, so it is just you can say representation for the resin, acidic resin. It is not having exact balancing that way, but since I had mentioned H plus resin, so I have mentioned here calcium resin twice, right, as per the valencies. Okay, so this part is called as ion exchanger. Which part is being exchanged here? The calcium ion, cationic part. So this is called as cation exchanger part or the cation exchanger resin. The basic resin will be an ion exchanger. In the similar way, this part will exchange chloride or sulfate present there. The interesting fact about this method is the soft water will not have any kind of salt. It won't be salty water. In permutate method, as I said, the byproduct or the exchange process gave the sample of water the sodium salt in the form of chloride or maybe in the form of sulfate. But here, when the sample of water passes through each individual compartments, the first compartment will exchange calcium ions and the exchanger is H plus. The second compartment will exchange chloride ions and the exchanger is hydroxide. So ultimately, this combination is not giving any kind of salt in that soft water. So this method gives finally salty water and this method does not give salty water. Although both the methods are giving us soft water, but that soft water is salty in this case but not salty in this case. Concluding the things, I will tell you about these two methods, that the commercial method of softening of hard water is permutate method. Although we can get salt free water from this method, but it is not an economical method. That is why the commercial method used for softening of hard water is permutate method. Now, last one more point related to the hard and soft water is about the quantitative measurement of hardness in water. For this thing, let us recall few points which are already taken in the initial part of this lecture. Recall the qualitative test also, qualitative test of hardness. Qualitative test of hardness is not as such very perfect. The only thing is calcium or magnesium ions present in hard water, actually they are in so less quantity that we cannot apply the usual test of calcium or magnesium as we apply for the salt analysis. Here the qualitative test of hardness is only that with soap, the sample of water taken with soap, right? So qualitative test of hardness is done with soap. However, the important is quantitative test of hardness. See, whether the sample is hard or not, this is qualitative test, and the sample contains, up to what extent the sample contains hardness causing agent, that estimation, that quantitative part is included in the quantitative test of hardness, or rather I should write quantitative analysis of hardness, the quantitative estimation of hardness. When we talk about the quantitative test, quantitative analysis or quantitative estimation of hardness, then one thing should be clear in our mind, that we have hardness in water in such a small quantity that concentration of calcium or magnesium salt is expressed in parts per million. I hope you know parts per million concentration. The parts per million concentration involves the weight of calcium or magnesium ions into 10 to the power 6 by the weight of water. See, normally what happens that the quantitative analysis is done in the terms of percentage. How much percentage of a substance is present in the sample of say if we are talking about water only and its hardness only. So the normal expression would be in terms of percentage, but percentage could only be used when the hardness causing agent would be in appreciable amount. Now had the hardness causing agent been in the appreciable amount, it would be in the form of percentage, but here I have taken it 10 to the power 6, means per millionth part. If I take the total quantity of water, then in its 1 millionth part, how much quantity of the hardness causing agent is present is called as quantitative hardness. Now for this purpose, the calcium or magnesium ions present, they must be brought in the form of insoluble substances. Because how to know about that substance? What will be the quantity of that substance? How to measure that? So first we convert the dissolved calcium or magnesium ions in the form of some insoluble substance, and usually a chemical substance, ethylene diamine tetraacetic acid, is used for this purpose. I repeat, EDTA. I repeat, this EDTA is actually ethylene diamine tetraacetic acid. Ethylene diamine tetraacetic acid. It is actually a hardness causing agent. I am sorry, it is not actually hardness causing agent, but it is actually the substance which is used to convert hardness causing agent into a complex which is insoluble in water. This is the formula. Ethylene diamine tetraacetic acid. It is a complexing agent. EDTA has a property to form complex with calcium or the magnesium ions. The complex formed between the two is water insoluble. So just consider, if we take 1 million gram of water, right? 1 million gram of water is taken. From that water, 1 million gram, that is 10 to the power 6 grams of water is taken, right? And now in this 10 to the power 6 grams of water, EDTA is added. On addition of EDTA, a complex will be formed between calcium ions or the magnesium ions and EDTA. This will be insoluble. So a precipitate will appear. It will be filtered. It will be dried. And the mass of that precipitate is then observed. Taking the mass of that precipitate in the form of weight of calcium or magnesium ions, that mass can be converted into the mass of calcium or magnesium ions in that complex. Placing the values over here, you can quantitatively determine the parts per million concentration of hardness causing agent in water. Suppose I get 1 gram of calcium ions or 1 gram of magnesium ions in that quantity. The quantity I said 1 million gram. So in 1 million gram of water, if I get 1 gram of calcium, just for example I am telling you, so the ppm concentration of hardness causing substances will be 1 ppm, 1 parts per million, right? So this way, simply it is a concentration expression. The method involves complex formation with EDTA. It is in fact called as EDTA method of estimation of hardness in the water, in the sample of water. So this is all about the topic hard and soft water. Now I would like to tell you one thing about the weightage of this topic. Continuously for last many years, when you will observe the type of questions related to water, then many a times you will find the questions based on concept of hard and soft water are repeated. Sometimes it has been directly asked that which of the following compound is a hardness causing agent, which of the following compound is not a hardness causing agent, presence of which compound in a salt makes it hard, presence of which compound in water makes it hard, what will be the appropriate method to remove hardness from water, what is the commercial method used to remove hardness from water, which chemical substance is used as ion exchanger in the permutate method, what are the temporary hardness causing agents, which of the following methods is suitable for the removal of temporary hardness from water, which chemical substance is used for the quantitative estimation of hardness in water, which concentration term will be used for the expression of hardness in water. Number of times this type of questions are asked. When you will go through the previous year questions, you will find number of questions in almost all competitive exams based on this topic. So it is one of the very happening topics, that is the concept of hard and soft water. Now after this, one more part is left with hydrogen and its compounds, that is about hydrogen peroxide. So that will be included in my next lecture. Thank you.